why, maybe. Yeah, so very distinctive colour. Lovely, beautiful green colour here. This is a really important rock group called a green sand, okay? It is made from the green colour comes from a mineral called glauconite. Now glauconite is related to a type of mica, so it's a very, very small mineral compound, and it is actually primarily formed by lots of biological activity, particularly secretion, so in other words, fish poo. Okay, so what it tells us is that we had a very rich ecosystem on a continental shelf. So there's another sort of pressure variable here, is that it generally forms only on continental shelf environments. Okay, so what it's telling you is you had a really healthy ocean with lots and lots of animal life, lots of burrows through here. If you look hard enough, there's shark's teeth in some of these, and some of the stuff in here. My students have found a couple of shark's teeth. Same with this rock we're going to look at in a minute. But also, the other thing about glauconite is because of where it comes from with the animal byproducts, it's very high in phosphates. And so this is actually often a very important resource for a lot of locals in terms of fertiliser. So if you're a farm around here and you've got green sand on your property, you can actually use some of your own material to supplement instead of having to buy stuff. So actually I think the foresters are potentially looking at this. This stuff actually has got quite some patches of very high glauconite content, which is why it's quite a dark green. So you can see that sort of in the ground around here, and there's some actually lovely, you can see it's quite sandy. So it is a sandstone, it's made of sand. There's some lovely little bits here. You'll see it's got quite a knobbly texture. Those are all the burrows that were sort of made through it when it was being formed.
This looks soft. Why has it eroded away?
It is soft, but it's still lithified, so it is still held together. But it's primarily held together by things like calcium carbonate, which dissolve under rainwater. And so, it does erode eventually over time. It is still hard. If you go up there, you still need a hammer to try and pick into it. But relatively speaking, unlike the limestone, it is a lot softer,
So that's
more
weird
erodible.
stuff down here.
So that's the next rock unit, which is more erodible again. So yeah, there's a boundary here. You can actually see where it changes colour to more grey. Suddenly stop the glauconite. So that's the deeper water. So we're going from shallow water with the limestone to deeper water continental shelf, and then we're going into deeper water again on the next sequence. Okay, so we're changing our ocean environment deeper water as we're going back in time. So what this is telling us back in time is at the time it got shallower. This is showing New Zealand coming out of the water that way. Okay, because we're going back in time. So we're sort of looking at it in the wrong direction, but you get the idea. Yeah, so we're going back in time to a more deeper ocean.